Let us now study how to measure the internal resistance of a cell by using a potentiometer. Okay, we earlier learned that a cell will have a internal resistance. Okay, so let's take the potentiometer circuit. This is a potentiometer circuit, and this is a wire here. CD is a potentiometer wire. Okay, this is a primary circuit. Battery key K1. Okay, then we have this thing wire here coming down, and CD is a potentiometer wire. Then down below we have the secondary circuit. Okay, in the secondary circuit you can see there is a primary cell, a galvanometer and high resistance in series, and then it's come to a jockey. Okay, down below we have a resistor and a key K2. Okay, this is another key. First we have kept the key K2 open. Okay, the key that is K2 is open. Open means what happens? This side there will be no current going inside. Okay, there's no current going inside, so it will be like this way only. Okay, so let me write this down. So first case is the key K2 is open. K2 is open. Okay, when K2 is open, what happens is this circuit, this resistor is not included. It's like this way only. Okay, this EMF is there now. This cell will give a EMF here, and this battery EMF, battery voltage will try to balance each other. Okay, we move the jockey left and right so that the galvanometer shows null deflection, and then you take the balancing length, that is L1. Okay, so in that case we can see the EMF is directly proportional to L1. The EMF of the primary cell E1 is directly proportional, or you can just write EMF itself. Okay, just write EMF is directly proportional to L1. Okay, then next what we do now, okay, after doing this, after finding L1, we have to close the K2, close this thing. Okay, so what happens is current will start flowing inside the resistor also. There is a resistor here. Okay, we have to choose a suitable resistor, say 10 ohms, and then we must again move the jockey left and right so that we'll balance it. Say at that time the new balancing length will be, it will be L2. Say it's L2. Okay, that's new balancing length. Okay, now let's see what happens now. K2 is now closed. K2 is closed. When K2 is closed, what happens? Okay, see, we must find the voltage now. Okay, see, we studied now earlier how to find the internal resistance of cell. Okay, if you just simply take a cell and connect a voltmeter, it will show you the EMF. But if you keep a resistor also and then find the thing, the voltage, that will show us the voltage only. Okay, so we now find the voltage here. V we must find. Okay, so for that what we do, we use the Ohm's law. Okay, right this side. Using Ohm's law, we have V is equal to I into R. Okay, then instead of V, okay, this battery EMF is there. Okay, so we write as the EMF is I is equal to I into, now see what will be the resistance here. This is the resistance R now. Okay, and then the cell will also have an internal resistance. That internal resistance is small r. Okay, so the new resistance, the total resistance will be capital R plus small r. Okay, we must find the current first. So bring this thing down. So what happens is I by capital R plus small r is equal to I. Okay, write little bit bigger, so it's more easy to see. Okay, write same thing, little bigger in size. So Xi by capital R plus small r is equal to I. Okay, so now we know how to find the current I. So I is equal to Xi, that's EMF here, by capital R plus smaller. Okay, very simple only. Next, after finding that, what you must do, you must find the voltage here. Okay, so using Ohm's law. So using Ohm's law, what happens is V is equal to I into R. Okay, this is a formula for Ohm's law. So V is equal to I, instead of I we have this Xi into divided by R plus small r, and into this R here. So into R. Okay, we got the step here. Now if you see in this case, we also find that, okay, also find that the voltage is directly proportional to the balancing length L2. Okay, so we have found the balancing length L2 now, so that will be proportional to voltage. Okay, so what we have to do is, let's name this as equation 1. Okay, and I'm going to use this thing, instead of V I'm going to write this symbol here, this thing, right this side. So what we get is Xi into R by capital R plus small r, okay, is directly proportional to L2. So now what I done is, instead of writing V, I have written this formula here. Okay, then let this be equation number 2. So divide equation 1 by 2. Okay, so divide equation 1 by equation 2. So when you divide this, what we get? So xi by xi into r by capital R plus small r, xeno. Okay, that will be equal to, and proportion sign will cancel, so we get division only. Okay, sorry, when you divide it, we get equal to sign. Okay, so it will come as L1 by L2. Okay, now see, xi and xi will cancel, so you get here 1 only on top, and you take this r plus small r, you take it up. So what will happen is, it here r plus small r by capital R is equal to L1 by L2. Okay, now what we can do, we can just split and write the denominators. Okay, so I'll write the center here. Okay, wrap this part just to continue. Okay, then let's see this now. I'll take this equation, denominator we can take separately now. Okay, so what you get is capital R plus small r. Okay, and then denominator I said take separately. This will be capital R here divided by capital R is equal to L1 by L2. Okay, it's very simple. Just see here. So R and R will cancel. So we get here 1. So 1 plus small r by capital R is equal to L1 by L2. Okay. So what is our aim here? Our aim is to find the internal resistance. Internal resistance symbol is small r. So we want to find smaller only. So you take this plus 1. Okay, and you take this side. It will become as minus. Okay. So what happens is, we get here R by capital R is equal to L1 by L2 minus 1. Okay, our aim is what? Our aim is to find smaller only. So multiply this side. Okay, multiply the capital R this side. So we get small r is equal to capital R into L1 by L2 minus 1. Okay, now we can take the L2 this side. Okay, we can multiply this and see, take LCM and do that. So we get here R is equal to capital R into L1 minus, and L2 goes this side now, multiply, okay, by L2. That means this means 1 by 1 only. 1 means 1 by 1. So denominator we get here LCM is L2, and then we cross multiply here. Okay, so we get here small r is equal to capital R into L1 minus L2 by L2. So it's very easy to get the internal resistance here using a potentiometer. This is a very important 5-mark question we have. So small r means the internal resistance, capital R means what? It means the external resistor. Then L1, L2 means the balancing lengths. Okay, L1 is when the K2 is open, and L2 is when the K2 is closed. Okay, so by you finding the balancing lengths and we know the resistance, we can easily find the internal resistance. Okay, so it's easy to find it. It's an important application of a potentiometer. Okay, thank you for watching. Just see this thing here, note it down. Okay, go through steps easily. It's very simple only. Thank you for watching.